All right, let's get right into it. We're going to talk about a radio technology that's been quietly changing the game, all the way from tiny sensors in our cities to trackers floating at the very edge of space. Welcome to our explainer on LoRa.
So, here's a question for you. How would you do it? How would you send a piece of data across miles and miles, using just a tiny, minuscule amount of energy? I mean, it sounds almost impossible, doesn't it?
Well, the answer is a really clever piece of tech called LoRa. It actually stands for long range, and this is the secret sauce behind a whole new wave of connected devices. Today we're going to break down exactly how it works and, why it's turning out to be so revolutionary.
So let's start with the absolute basics. I want you to think of LoRa not as a big, loud shout, but more like a carefully engineered whisper that can somehow be heard from miles and miles away.
See, at its core, LoRa is built for two things: incredible range and extremely low power consumption. This combo makes it absolutely perfect for the Internet of Things, battery-powered sensors that just need to send little bits of data over huge distances. But the best part? It operates on license-free frequencies, and the hardware is super cheap, which has opened the door for a massive wave of creativity from hobbyists and experimenters.
So how does it actually pull off this magic trick, this combination of insane range and sipping power? Well, the answer lies in a technique that was borrowed from military communications and, believe it or not, was partly inspired by a Hollywood actress way back in the 1940s. At the heart of LoRa is this thing called chirp spread spectrum. Now, instead of transmitting on just one fixed frequency, a LoRa signal is a chirp that literally sweeps across a whole band of frequencies. This makes the signal incredibly robust. It can be picked out even when it's technically weaker than the background radio noise. And that right there is the key to its long-range, low-power performance.
And this comparison illustrates it perfectly. A traditional radio signal? That's like trying to hear a single, quiet flute note in a really loud room. It just gets drowned out. But LoRa's spread spectrum signal, that's like hearing a full musical chord. Even in that same noisy room, your brain can pick out the chord because it covers a wider range of tones. That's exactly how LoRa resists interference. And you can control this with a key setting called the spreading factor. The easiest way to think of it is like a trade-off knob. You can turn it up for maximum range and reliability, but your data rate slows down to a crawl. Or you can turn it down for shorter distances, and you can send data much, much faster. It's this flexibility that makes LoRa so darn versatile.
Okay, one last bit of tech before we get to the really fun stuff. The difference between LoRa and LoRaWAN. Now, this trips a lot of people up. Just remember, LoRa is the physical radio part. It's the how a signal gets sent. LoRaWAN, on the other hand, is the network protocol that runs on top of it. It manages gateways and servers. It handles the who and where for big, large-scale deployments. A lot of hobbyists, though, they just use LoRa directly for their own awesome custom projects. And it's this combination of low cost and high performance that has created something truly special. We're talking about a genuine revolution among amateur radio operators and makers. Because you got to understand, this tech isn't just for big corporations deploying thousands of sensors. No way. It's for the tinkerer in their garage, the student with a cool science project, or the hiker who just wants to stay connected when they're off-grid. That accessibility, that's what's driving this whole new era of innovation.
And just look at what people are doing with it. The amateur radio community is supercharging old systems like APRS. Get this, one user reported a 32-mile connection using just 1/10 of a watt of power. People are building these amazing mesh networks for off-grid texting with projects like MeshTestic, and some are even pushing the limits trying to send digital voice over these low-speed links.
Which brings us to what might be the most exciting application yet, a competition that aims to take this humble, low-power technology and send it soaring right into the stratosphere.
Yeah, 90,000 feet. Let that sink in for a second. That's over 27 kilometers straight up. We are well into the stratosphere here. We're talking the region where weather balloons and spy planes fly.
And that's the goal. It's for a competition being run by the Radio Society of Great Britain. They're launching a high-altitude balloon with a LoRa repeater on it. And the challenge for everyone on the ground is to see if they can send a signal all the way up there and get it repeated back down.
So here are the rules of the game. Let's look at these parameters. Notice that spreading factor? It's set to 12. That's the highest possible value, maximizing range over speed. And then check out the power limit, just 200 milliwatts. They are really truly pushing the limits of what this low-power radio can do.
So right about now, you might be thinking,
Okay, this sounds amazing, but it must be incredibly complicated to get involved. Well, the whole point of this competition is to show you that it really, really isn't.
The recommended hardware is this little board right here, the Heltec Wireless Tracker. And this thing is an absolute marvel. For a super low cost, it packs a full computer, a powerful LoRa radio, GPS, Wi-Fi, and even a little screen into a device that you can hold in the palm of your hand.
The organizers have broken the entire setup process down into 4 pretty straightforward steps. You get the board, you install some free software tools on your computer, you compile the ready-made code, and then you just upload it to your device. It's literally designed to be accessible even for people who have never written a line of code in their life.
And once you've done that, you have a device in your hands capable of bouncing a radio signal off a repeater floating at the very edge of our atmosphere. This quote from the official guide really says it all. The goal isn't just to have a contest, it's to demonstrate just how accessible this incredible technology has become. It's all about empowering people to build, to configure, and to experiment with hardware that can do some truly extraordinary things.
Ultimately, this is so much bigger than just one event. This whole competition is a perfect example of the democratization of technology. I mean, what was once complex, expensive, military-grade tech is now a tool for creativity and exploration, and it's available to anyone with a little bit of curiosity.
It really makes you think, doesn't it? When a device that you can program on your kitchen table can communicate with the Stratosphere, well, the old limits just don't really apply anymore. The only real question left is, what will you build next?